Welcome to my AI Learning Design presentation titled Implementing AI Course Assistance, a rapid design case from concept to full rollout at Los Angeles Pacific University. At Los Angeles Pacific University, the design of Spark AI Course Assistant was driven by a student-first philosophy, transforming AI from a potential academic threat into a catalyst for learning. Grounded in Gabriel's behavioral engineering model, the digital learning solutions team envisioned an ecosystem where Spark acts as a thinking partner for adult learners. First, the activity, Socratic tutoring. Spark acts as a coach that never provides direct answers. Instead, it ends every response with a guiding question to prompt student reflection. Next, the tool. The Nectar platform provides a specialized interface with strict guardrails, ensuring the AI stays within defined academic boundaries. For the system, LEI integration plugs Spark directly into the online classroom. This creates a seamless, low-friction experience where students never need to manage separate accounts. Finally, the workflow. Through a standardized sprint, the digital learning solutions team executed a rapid 4-week rollout, successfully deploying Spark to over 160 courses simultaneously. Learners and context at Los Angeles Pacific University are defined by the needs of adult students juggling work and family in a fully online, faith-based environment. To support them, the design team provided a 24/7 support system that mimics a live instructor, embedding the AI directly into the online classroom to create a safe, accessible space. Their context focus is radically student-centered. This requires them to balance constant accessibility for remote learners with a strategic implementation of tools that safeguard academic integrity and prevent cheating. To improve approachability, they prioritize psychological safety. They use intentional design choices, such as friendly visual personas like sci-fi or Lucas, to lower psychological barriers and reduce AI anxiety. This builds immediate trust, allowing students to engage with the material at their own pace in a secure and supportive environment. Learning objectives and outcomes for the Spark AI project focused on shifting the role of technology from a content provider to a cognitive thinking partner. By prioritizing higher-order thinking over simple automation, the design aimed to increase student agency and metacognition. The primary goal was to ensure students could articulate their reasoning and justify their academic conclusions, leading to measurable increases in student confidence and engagement with difficult course concepts. To achieve this, the design focused on 4 specific areas. In critical thinking, Spark was implemented to help students learn how to learn by prompting them to explain their thought processes. Regarding engagement, pilot results indicated that students using the tool provided more thoughtful and original contributions to class discussions. For student agency, the outcome was to move students away from passive consumption toward active problem-solving and independent inquiry. Finally, in terms of confidence, qualitative feedback showed that students felt less alone and more confident when tackling complex assignments at any hour. The pedagogical approaches for Spark are rooted in the Socratic method and active learning, shifting the AI from a content provider to a thinking partner. Using Gabriel's behavioral engineering model, the team focused on providing environmental prompts and cognitive scaffolding to trigger student engagement. First, the Socratic method provides inquiry-based guidance. As the core strategy, Spark is programmed to offer hints and end every interaction with a question to stimulate deeper thinking. Next, active learning uses cognitive scaffolding. Spark acts as a partner in activities like Think, Pair, Share, helping students practice the real-world application of theory. The behavioral engineering model focuses on timing and delivery, ensuring students receive the right tools and information at the precise moment needed to bridge knowledge gaps. Finally, role-play offers simulated interaction. By adopting personas like a therapy client or historical figure, the AI provides a safe space for practicing professional skills. This design ensures that students must articulate their own reasoning and understanding rather than simply receiving answers. How GenAI supported learning was defined by its role as a scalable, 24/7 teaching assistant that provided personalized, just-in-time guidance. By moving beyond simple content generation, they configured the AI to act as a pedagogical partner that understood the specific context of each course. This supported learning by offering students a safe space to practice skills and receive immediate feedback, effectively bridging the gap between independent study and instructor interaction. To implement this, they used course-specific tuning, training the AI on curated PDFs, so the support was always relevant to specific readings and assignments. They also introduced simulated practice, where the AI adopted personas, like a therapy client or a historical figure, to help students apply theory in a professional context. For just-in-time support, the AI's 24/7 availability provided Socratic guidance during non-traditional hours when faculty were unavailable. Finally, they created feedback loops for iterative reflection, where instant feedback prompted students to refine their thoughts through continuous dialogue. Together, these mechanisms ensured that the technology acted as a continuous support system for student growth. Reflecting on the project, the team realized that while the initial rapid design was successful for speed, several manual processes needed to evolve for long-term sustainability. The transition from an emergency response to permanent infrastructure revealed friction points in both the user experience and data management. By acknowledging these early inefficiencies, the team identified the key shifts required to move from a pilot phase to a robust, automated institutional standard. Regarding data handling, they moved away from manual PDF creation toward automated SQL database pulls to ensure greater accuracy. For user access, the team replaced separate logins with a seamless, single-click learning tools interoperability (LTI) integration, embedding the tool directly into the classroom so students no longer need a second account. In terms of content preparation, they shifted from human-curated modules to automated content scrapers that pull syllabus and assignment data without manual copying. Finally, they improved sustainability by moving from rapid 4-week sprints to a standardized, repeatable maintenance cycle. These improvements transformed an emergency rollout into a scalable, permanent framework for student success. If I were an independent contractor, my focus would shift from the initial emergency rollout to long-term optimization and proving the return on investment. I would focus on refining the project to ensure it is measurable and scalable across the institution. First, for student readiness, I would implement a mandatory AI literacy module to teach prompt engineering. This ensures students aren't frustrated by Spark's refusal to give direct answers. Next, for quality control, I would establish monthly human-in-the-loop audits. This protocol checks Spark's interactions against course rubrics to ensure Socratic hints are pedagogically accurate. To prove long-term impact, I would track metacognitive data by monitoring student performance in subsequent courses where the AI isn't present. This proves that Spark successfully improved independent critical thinking. For faculty growth, I would create a prompt marketplace. This shared library allows faculty to exchange successful prompt recipes across different disciplines. Finally, for transparency, I would provide AI nutrition labels listing the specific data sources authorized for use each week. These shifts move the project from a pilot phase to a robust, institutional standard. The Spark implementation at Los Angeles Pacific University provided insights into merging human pedagogy with AI. These points summarize the team's lessons during the design and rollout. First, faculty buy-in. Culture matters more than tech. Involving faculty as co-designers turned skeptics into advocates. Second, data integrity. Constraints are powerful. Limiting the AI to specific documents prevented hallucinations and ensured accuracy. Third, agile design. They used a good enough strategy, launching quickly and refining based on student feedback. Fourth, pedagogy. AI acts as a partner. Socratic methods made the AI a thinking mirror rather than an answer machine. Fifth, user experience. Friction is the enemy. Embedding Spark directly into the classroom removed barriers to usage. Sixth, engagement. Visual personas were effective. Friendly avatars lowered AI anxiety and encouraged students to ask questions. Finally, scalability. Standardized sprints allowed a launch across over 160 courses. Together, these lessons highlight the importance of balancing technical speed with human-centered design. Reference: Hanshaw, G. and Wilday, M. 2025. Implementing AI Course Assistance, a rapid design case from concept to full rollout at Los Angeles Pacific University. International Journal of Designs for Learning. AI Disclosure Statement. This presentation was developed in collaboration with Google's Gemini Guided Learning, which was used to support content curation and image creation. All AI-generated text and visuals were reviewed, edited, and verified by me to ensure accuracy, clarity, and alignment with the presentation's objectives. I used Narrakeet for the video narration, subtitles, and MP3 output.